This is a continuation of Cox Learning System 3.3. We're going to talk a little bit about distance problems. Basically, there's two types of distance problems, and you just have to figure out which one you're dealing with. Oftentimes, you'll have a situation where you're going there and coming back, in which case your distance going there equals your distance coming back. So you'll end up with setting your distances equal to one another. That might also be the scenario if you are both traveling to a certain point, but maybe one's going faster than the other, that kind of thing. Or another type might be where you are headed towards each other. And you don't really know necessarily that your distances are the same because one's maybe going faster, but you do know that your total distance is given. So it would be the scenario where you take your distance plus the other guy's distance that's coming towards you, and it equals some total amount that's given to you. So each time you're going to set either your distances equal or add them up and set them equal to a total. So let's try one. I'm going to spend 3 hours training for a race. I train by running full speed the distance of the race and walking back the same distance to cool down. Okay, so that means I'm running there and then I'm walking back, and you can see, okay, well, whether I'm going or coming, the distances are the same, so it'll be a scenario where I set my distance running equal to my distance walking. It does say that I run 10 miles per hour and I walk 2 miles per hour. How long will it take to walk back? So let's set up our two scenarios. Here's my distance 1 equals rate times time, and then I'll have distance 2, which is walking back, rate times time, but perhaps a different rate in time. So on the running scenario, my rate was given, I run 10 miles per hour, and the time that it takes me, I don't really know. That's kind of part of what they're asking, is how long it takes. I do know I have a total of 3 hours, but not all of that's running, so I'm just going to leave that T for the time that I'm running. Over here, I have D2 equals the rate, okay, walking, that's a 2, and then my time, again, I don't really know the time. But I do know that I walked, or I had a total of 3 hours. And if I spent T of it running, then I can just subtract that from 3 to see how long I must have spent walking. And once you get those two equations, then we're just going to take those two things and set them equal to one another. So 10T is going to be equal to 2 times 3 minus T. And then let's go solve. We'll have 10T equals 6 minus 2T. Add the 2T over to the other side and divide by 12. So T actually ends up equaling 1/2. Remember that that's in hours. So I spent 1/2 of an hour. If you recall, T represents the time running. So I spent a ½ hour running. The question actually asked, though, how long will it take to walk back? Well, that's over here, and so that's going to be 3 minus 1/2. So my official answer on this is that I spent 2½ hours walking. All right, let's look at another one. This is a train that leaves New York at 3 p.m. A second train going the same direction leaves New York at 7 p.m. The second train travels 72 miles per hour faster. Now, the second train overtakes the first at 10 p.m. What's the speed of the two trains? All right, so let's kind of set this up. I've got a train going this direction. It leaves at 3 p.m., but I have another train at the same spot leaving and going the same direction, but they started later, but they're moving faster, so at some point they're going to catch up. And that's the point that, we're looking at. So look, those distances would be the same. So this will be a scenario where we take our first train distance, set it equal to our second train's distance. So I have D1 for the first train, and that's rate times time. So let's fill in what we know. The rate of that train, I don't really know. So I'll leave it R. And the time, well, it left at 3, and we're talking about the time that it takes